Let me give you a kind of a big picture of what we're going to be doing today for this assignment, 5-4. We're going to take number 8 from what you just did on homework last night, and it came out to 7 plus or minus root negative 47 all over 8. Now, up to this point, the answer to this, when you get something like this, you say the answer is no solution because, yeah, you can't take the square root of a negative. This is what you guys said in Algebra 1. So what we're going to do from here is that we're actually going to finally address this whole taking the square root of a negative and actually find out that there are solutions to this. Here's the thing, is that before when we said no solution, it meant there's no real solutions. We're talking about real number, okay? Real number solution. There's no numbers in the reals or the set of real numbers that will solve this problem. However, there are other numbers that will. So the transition you'll make, so from Algebra 1 to Algebra 2, is that when you see a negative in the square root, you're going to start seeing this value called I show up. And instead of having a square root of negative, whenever you get that square root of negative, instead of just leaving it in there, we're going to get rid of it and have an I on the outside. This is what you're going to do in Algebra 2 and up. Everything after Algebra 2. Basically everything in your life from this point on, you'll never say square root of negative, no solution. You will not say that anymore. If you do say no solution, make sure you say there's no real number solution. However, there is an imaginary set of numbers that we use to address this problem. And actually, you're going to do one more step on here, and that's the distributive property. You're actually going to divide it up and say, well, there's this real part of the answer. That's just the regular numbers. And then there's this other part, the imaginary part. I get that just by distributing at the bottom. And if there is no number on the bottom, then 7 would be the real part, and the plus or minus I through 47 would be the imaginary part. So we have two parts to our answers, the real and the imaginary. So we're going to be talking about imaginary numbers for today and tomorrow. And then we're going to go back and actually do more factoring and more square roots and more quadratic formula. However, when you get negatives on those problems, you'll start doing this as well. So from this point forward, anytime you get a negative square root, you're going to start doing this. And have two parts to your answer. Notice how where we just left it all over 8 before, whenever you have an imaginary part, you actually split it up into 2 parts like this. So a few things on, here's how you write your answer from now on. And if you like, okay, here's a new, we won't call it variable because it's actually a number. It's kind of like the number pi. It actually stands for something. And again, this I, what does the I actually stand for? We put it in there instead of putting square root of -1. It's our way of taking a square root of a negative. And actually, it's used quite often. You might think of this thing, well, I haven't seen it ever. I haven't seen this imaginary number. I've known my whole life I can't take square roots of negatives. And now this guy is telling me, yeah, you can. Yeah, that's the case. And it's actually used very often in real life. And mostly, number one application I can think of is in electricity. When you have a certain kind of power called alternating current, that's like AC, there's AC and then there's DC, direct current. Alternating current actually has current flowing both directions. It flows from A to B and B to A. That's why it's called alternate. It goes back and forth. Unfortunately, it's very difficult to calculate one at a time. So what they can do is they can use the real numbers to calculate the flow in one direction. They can use the imaginary to opposite the flow in the other direction. So if anybody ever gets into like electrical engineering, you actually use this all the time. Talk about, well, what direction flow is a current, how strong in what direction, things like that. So it's actually used very, very often, anything electrical. So yes, anything in your phone, anything in the lights turned on, power outages and stuff, this is what's actually used to fix problems or create new machines with electricity. So I just don't want you to think imaginary as, you know, some person just imagined this. It's kind of nice, and, you know, imaginary. It's actually very concrete, very real. That's what you So, going back here, we're going to be looking at all these imaginary numbers. All these imaginary numbers. Or, let's just remember, using your calculator or just breaking it down on your own, root 45, how does that simplify exactly? Root what times root what? 9 times root 5. Remember, one of the numbers, the first number, had to be a perfect square. It has to be 4, 9, 16, 25, 36, 29. Has to be a perfect square. Because the next step is to actually take the square root of that first number. So we have 3 root 5. So what's going to happen now if you have a square root of negative 45? What's the difference between square root of 45 and square root of negative 45? So before we broke it up into 9 and 5, but now we have a negative. The negative is the same as what number? Negative is the same as, yeah, if I said like negative x, that means negative 1x, right? So negative 45, we can actually break it up to negative 1. And then 9, and then 5. So everything's the same as up here, except, yeah, we have a negative, so we have a square root of a negative 1. And then you're going to find that you'll be thinking this, and then the more you do it, the more it'll be true. And that statement is, oh, this is basically the same thing as we did before. And that's true. You're still going to break it up into 9 and 5. You're still going to take the square root of 9 and get 3. You still can't take the square root of 5, so you're still going to leave that as root 5. That hasn't changed. But now we have this square root of negative 1. As I mentioned before, we're going to call this I. And just like before, if we had x times 3, usually going to write x3. You write 3x. Right? Same thing here. If we have I times 3, we're going to write that as 3i. And I always put that coefficient first. So look very closely in what we have on our both of our answers. What do we get for positive root 45? 3 root 5. What do we get for root negative 45? 3i root 5. What's the difference between the two?
I.
Yeah. There's an I in this one because there's a negative. So basically every time you have a negative to start, in your final answer, you'll see it as an I. That's the big idea here. Negative square roots are imaginary numbers, or negative 1, square root of a negative 1. So we'll have this value I in that kind of answer. This is an imaginary number. Because it has an I, it's imaginary. But if you look from what you've been doing your whole life with radicals and what you're doing now, yeah, 2/3 of it is exactly the same. Still break it up to root 9 root 5, make it 3 root 5. It's just now between the 3 and root 5, we have this I staying in place for the negative inside the square root. Alright, so let's play a little bit more. I want you guys just to practice a second here. So what is the square root of negative 12? Right. Square root of negative 12. Write that down. Simplify it. How would you simplify square root of positive 12? What would that be? Square root of positive 12 is? Well, 4 times 3 is positive 12. Right? We have to know that positive 12 is 4 and 3. But now we have a negative, so it's negative 1 also. So we have square root of negative 1 is pi. Square root of 4 is, and square root of 3 is root of 3. Yeah, you can't take the square root of 3, so we just leave it as it is. And then of course, the unit property, we don't usually write I times 2, we just write 2. What would that look like negative 16? See, 16 is an actual perfect square, so that's square root of negative 1 times the square root of 16, which is, yeah, 4. Yeah, so you guys do one. Try that on your own, see if you got it. Okay. So, what do we got? What's 32? Break down to 16 and. Now, if you didn't get 16 and 2, realize that's algebra 1. So if you're not getting this part, I just want you to know, if you're asking for help, then yeah, I can't get that algebra 1 part. How do I know how to do this part? Okay. So remember, the first number just has to be the largest perfect square. Some of you might have been tempted to do 4 and 8. Because 4 is a perfect square, but it's not the largest perfect square. So between 4 and 16, you have to take 16 because it's larger and it still goes into 32. So you want to use 16, not 4. So yeah, we get 4 root 2. However, since this is a negative, we'll have the square root of negative 1 as well, which is equal to I, and then your answer is 4I. And there'll be other instances where you're going to write it as 4 root 2I. So you'll see this move around, just know that they're all the same and mean the same thing. It's just depending on the certain problems. Answers you're looking at. I think mostly you'll be sticking to this one for in the short term. Good. All right. So now let's look at. So now we know what this I is. We want to actually look for a pattern for all these I's. So here's the big picture for this. I'm going to give you something like I to the 45, I to the 31, and you want to know what that equals rather quickly. So, I to the 1, we know is equal to square root of negative 1. And that's what I is. I to the first just equals I. Anything to the first power is just that base. Oh, little side note. Notice how I'm putting this little tail on the I. That's so that when I'm doing ones and I'm doing I's, they don't actually look the same. Okay. Put a little tail on it so you don't confuse your I with your 1. Just a little thing that goes a long way. And you know, when you get back that quiz or test and you realize, oh, I thought that was a 1. It's really an I. That's why I missed the whole thing because I couldn't, I'm not writing clearly. So small, but could make a difference in the long run. What would I to the second power be? Alright, so if, that, like, 2 to the second power means 2 times 2, right? So I to the second power, well, we know I is this, so root -1 times root -1. Now, using some more algebra 1, if you have like root 3 times root 3, what does that equal?
3, right?
Root 3 times root 3, what does that equal?
3.
3. Right? Because root 3 times root 3 is root 9, and square root times. Same thing here, root 5 times root 5 equals 5. Because root 5 times root 5 is 25, square root of 25 is 5. Well, same thing here. Notice how we can just totally not, like you guys are doing, just eliminate that whole middle step. Root 3 times root 3 into these parts inside the radical, called the radicants. If they're the same and you multiply them together, the answer is just the same thing without the square root. So square root of -1 times square root of -1, this equals, yeah, -1. Take it one more step. I to the third. Square root of -1 times square root of -1, square root of -1. And let's use what we already calculated prior to help us out. So we already know from one step above, well, if I have 2 of them, so let's say like these two, what is square root of -1 times square root of -1 equal? Equals -1. So we know this part's -1. Just those two. Just those two equal -1. After we found out. Okay. And what is square root of -1 equal?
I.
I. So I'm right here. Square root of -1 is just I. So it's a little lonely square root of -1. What is -1 times I? Negative I. It's like if you had -1 times x, that would be -x. -1 times I is -x. So now, so far, take a break for a second. We know I to the first is square root of -1 for I. We know I to the second equals -1. We know I to the third equals -I. And actually, if we went back and said, well, what is I to the 0? Anything to the 0 power equals 1, positive 1. Anything to 0 power except 0. 0 to 0 is kind of like students with that extra. But yeah, anything but 0 to the 0 power equals 1. 2 to the 0 equals 1. 5 to the 0 equals 1. -4/5 to the 0 power equals 1. Now, let's go ahead and find I to the 4th. So we could expand this out all the way. And I'm showing you this is because it's not going to be instinctual for a while. You're going to have to really think about what these things equal. And if you get stuck, you can always just recreate what we're doing right now and figure it out. And last resort on the test is like, okay, try to redo how this whole thing works, and maybe I can answer all these questions. Because there's going to be a lot of questions with these documents, so you're going to have to know that. All right, so what is, if I multiply 2 of them together, what do you get? Yeah, I squared is -1. So I know those two together equal -1, and I know these two together equal -1. So what is -1 times -1? Positive 1. How about that? Is there another positive 1 answer somewhere? Where else? Yeah, right up here. There's 0. you get, well, there's 4 i's, right?
1 times 1.
So we know we can kind of write like this. We know this is going to be I to the 4th times. If we have 5 total, that's like 4 i's and 1 more I. What is I to the 4th equal?
1.
Yeah, we found out that's 1. And I to the 1 just equals I. What's that 1? So we get an answer of I. I to the 5th equals I. Where else is another answer of? Yeah, I to the 1st. So I want you to observe and understand that there are repeating. What do you think would happen if we did I to the 6th?
It'd be 1.
It would be, well,
-1.
if everything's repeating, right? We started on 1, started repeating, then it went to I. What should come next? -1. Yeah, it repeats again. It just goes down the same 4 answers over again. So then you'd have I. What would be I to the 7th? Would be -I. Again, you can just see everything repeating. That's what you call it cyclical. It repeats itself. So again, the big question is, if I told you, well, if I asked you what I to the 45th is, can you figure that out without actually counting 8, 9, 10, 11, 12, 13, 14, all the way to 45? Can you figure that out?
Yes.
And if you can, which of course you can, how do you do that? How do you do that? It repeats every 4, right? It repeats every 4. Every 4 we go through, it goes back to 1. And once I get to I to the 4th, it's going to equal 1. I get to I to the 8th, it's going to equal 1. So what I can do is remove out all the full cycles. Every time it goes through, I can take them all out and see how many i's are left over. So, the question is, with 45, how many times does this whole cycle repeat? How many times before does this whole cycle end?
11.
11, right? So I go around 4 times. Okay. Around again, you're at 8. That's 2 times around. And you go another time around, 3 times around, now I got 12. So eventually, how many cycles can you go through? You can go through 11 times with 4, 44 times you can go through this, and you'll have 1 more left over. 44 and 1 is 45. And we know this time we go through it over and over and over, 4 times over and over and over. We know that part equals 1. Every single time, every multiple of 4. And then we have the I left over, which is equals I. The answer to the question that you will get really good at doing is I to the 45 just equals I. Same thing as I. And then go through again, again, again. It'd get right to here. The 44th time would be right here, and then 45 would be right here. Okay, so big idea. You want to have this pattern written down all the time. Okay? So you want to have, as you're doing these, or just until you have it committed to memory, I to the 0 equaling 1, equaling 0 power is 1. I to the 1 is equaling I. There we go. I to the 2nd equals -1. What else? I to the 3rd equals -I. Okay. And then you're looking at the remainder. You're going to divide this exponent by 4 and look at the remainder. Go ahead and divide 45 by 4. What do you get? What do you get? 11.25. Alright. The remainder, 0.25, 1 out of 4. The remainder, 0.25 is the remainder of 1. the answer is I to the first equals I to the, let's see here, I to the 10th. 10 divided by 4 is 0.5, which means our remainder is 2, or 2 out of 4. That's what the 5.5 is half. Equals -1. I to the 67, 67. What do you get there? 67 divided by 4 is something point 75, which means the remainder is 3. I to the 100. 100 divided by 4 is what? 25.0. No remainders. So if you get a 0.0 or a whole number, that's just I to the 0, which equals 1. If that's how you're going to use this, you're going to divide the decimal by 4. Look at just the decimal. It doesn't matter what is point whatever. I mean, whatever point is what's important. It doesn't matter what comes before the decimal. But look at after the decimal. So you want to start equating these. When you get a 0.25, that's I to the 1. If you get a 0.5, that's I to the 2. If you get a 0.75, that's I to the 3. And how do you know that? Remember, this is out of 4. So 1 out of 4 is 0.25. 2 out of 4 is 0.5. 3 out of 4 is 0.75. This is a table that's going to get you through all of this. Having this information will help you out in every way. So I to the 107. What's the decimal you get? 107 divided by 4 is 0.75. So that's I to the third. So the answer is just -I. But that's how fast we're going to be able to do these eventually. You'll have this table in memory. You can do 10 of these in a minute. Okay? Divide by 4, get a decimal. There's the answer. Divide it again by 4, get a decimal. There's the answer. Okay? They'll be really quick and fast. It's going to take a little getting used to. You will have to memorize this. So we'll be practicing with this over and over and over. Yeah.
What is when you divide it, it doesn't divide.
It always does, because if you divide any number by 4, it has to give you 1 answer. Yeah. Of course, any whole number. So your exponent's always going to be an integer. The same thing works for negatives. It'll just be negative 2.25. Still same thing. So it does not matter what the number is in front. It still works if this was I and then negative 107. Because this is going to give you negative something 0.75. So it's still the same answer. Positive, negative, doesn't matter. So let's look a little bit how this will be used. On your homework, you'll see things like this. You'll have to know, okay, these are regular numbers, 2 and 6, so we get -12. What is I times I? I squared. Okay, now what does I squared equal? Look at your chart, what does I squared equal? -1. See how that chart's so much easier? -12 times -1 is 12. Now you can see like 9 and 80, same thing we just did. 1, 2, 3, 4 is algebra 1. That's just review. We get to number 5. There's a square root of negative. If the square root of 36 is 6, the square root of -36 is 6 with an I. 6i. Now remember, every time you take the square root of negative, you'll just have an I. And same thing. What's 26? What's that answer? 12. Yeah. Square root of positive 144 is 12. Square root of negative 144 is 12i. And here you can see you'll have I times I squared, so we have an I to the third on this problem. And so use your chart. Anytime you get confused, use that chart, it'll help you. Yes? What's that? 23.
Oh,
Oh, number 22? 31.7. Yeah, that's just algebra 1. See how it reduces. What number goes in there? What does it wake up to? Draw in there. Try multiples of 4, 9, 16, 25, 36, 49, 64, and so on. 49. So we got 49 and how many times? 3. So 7. Yes. Yeah, if you got the square root of like 30, that's equals square root of 30. So just like fractions, not every radical reduces. A lot of these do because we're continuing to practice them, but once we get going through this, like you guys saw in your homework, sometimes you get like 8 plus or minus square root of 129 all over 2. And that doesn't reduce. You just have to get the decimal and start getting your 2 approximate answers. So not every radical reduces. It's just that right now we're practicing that when they do. Yeah. Yeah. Yeah, exactly. And then in 2 days, after tomorrow, tomorrow we're going to start graphing this stuff. So the next day, we'll look at quadratic formula again when we do get negatives, and we'll start looking at answers. Like I said at the very beginning here, when we have this type of answer for quadratic formula, start getting that. So that's in a couple days, but tonight we're just going to do the basics. Use that chart, commit that chart to memory. And you're going to need that chart on everything. Write it down over and over and over, and then after a while, it'll just be committed to memory. All right, I think we have the time period.
43.
43, so we have 7-8 minutes. Looking at how short these problems are, you might be able to finish the first 10 if you just start right now. Ask questions. If there's anything on that page right now that you don't know how to do, ask it before we leave. If you want to, look at number 30, look at number 55. If you're thinking, I don't know how to do those right now and ask for help now. Don't do the easy ones and go home and get stuck. Do the hard ones now, go home and do the easy ones, okay?